what is returns to scale? What are we trying to get at when we say returns to scale? What are we interested in? Basically, we're interested in what happens to our output if we scale all of our inputs by some amount at the same time. Okay, so I'll give an example. It'll hopefully become more clear. But to kind of set the scene, let's say we have a firm. It's producing some sort of output Y. This could kind of be anything. And it produces based on a production function F, some function of capital K and labor L. Okay? So say I'm going to scale up all of my inputs by some amount. Okay, let's call that Z. So we scale all inputs by Z. So let's say Z is 2. That would be a doubling of all of our inputs. Okay? So our sort of new production function with this scaled up inputs would look something like this. So it's the same production function. I've scaled up the amount of capital in there by Z. I have ZK. Same goes for labor because it's all of our inputs. That's the really important part. So I had ZL. Okay. Now, with increasing returns to scale, say for example, I decide to double all of my inputs. Exclusively with increasing returns to scale, we actually see our output more than double. So maybe I double all my inputs, I double the amount of capital, I double the amount of labor, I might get quadruple or maybe 5 times the output, so it's less maybe I'll get 5 times the output, okay? And that would be increasing returns to scale. So mathematically, that's going to look something like this, where the production function with the scaled up inputs is actually going to be greater than simply the scale factor Z multiplied by the original amount of capital and labor. Okay, so this is kind of quite daunting. It doesn't normally come too easily to students, and that's okay, but we're going to try and go through it now. So let's use that doubling example again. So say Z is 2. Okay, what this is saying, I'll write it out more explicitly, so maybe it's a bit easier. Okay, L, F. Okay, so what this is trying to say now is the doubling, so the amount we produce, the whole left-hand side of this equation here, when we double our inputs, actually greater than 2 times our original output. And our original output doesn't have the doubling up of the capital and labor. That's just the kind of benchmark. That's the starting point. So by doubling our inputs, we're actually getting more than double our original output. Okay, so that's your increasing returns to scale. The rest of these are fairly straightforward now. Constant returns to scale is sort of just this, where it's exactly equal. So ZK, ZL is equal to Z. These are Z. Okay, so say again we double. The amount we produce when we double our inputs is equal to Z multiplied by that original amount. Okay, so again, if we double inputs, we get exactly 2 times the original output. Decreasing returns to scale, DRS, hopefully follows this kind of fairly straightforward. We've got a greater than here, we have an equal here. It's just the less than. So I could have something like this. Okay, so basically what I'm saying here is that I can double my inputs, but I'm actually going to get less than double the original output. Okay, from a business point of view, that might not be fantastic. That might mean, oh, maybe I don't want to go ahead and double my inputs. I'm not going to get double the output. Okay, so yeah, that's kind of it. I'll keep it short. Just remember, this is a sort of generalizable principle. It's not just limited to this production function. It's not just limited to capital and labor. You could have anything here. Capital and labor is just kind of common go-to example. Yeah, that's pretty much it. Thank you.